Today we are starting the chapter real numbers. Before we begin, let me explain about what do you mean by the real number. So real numbers are the numbers that can be found on the number line that include both the rational and irrational numbers. Examples are we can write its examples like 1 by 2, minus 3, then even 0.75, it is also a real number. 5 is a real number. That means real numbers are the numbers which include the natural number, whole number, integers, rational numbers, irrational numbers, everything. Now, types of numbers. In types of number, we will be learning first about the natural number. I mean by this natural number, the counting numbers from 1 till infinity. Okay, so natural numbers are called what? They are the counting numbers. Okay, these numbers we use for counting objects. Here, therefore, what is not included? 0 is not included because 0 is not used for counting, right? Now, what about the whole number? Whole number means which include from where? From 0. It starts from 0 till infinity. That means what whole number is. So basically whole number means what? It is a natural numbers. Along with that we will be using 0 too. Then we have to learn about the integers. So what do you mean by integers? Integers include positive number, negative number and 0. For example, minus 3, minus 2, minus 1, 0, 1, 2, 3, like that it goes on. Okay. What about the rational number? Rational numbers are what? The number that can be written as a fraction. That means in the form a by b, where b is not equal to 0. That means denominator it should not be equal to 0. Examples: 1 by 2, 3 by 4, minus 5 by 2, even 0.75 I can write as a rational number. Why? 0.75 can be written as what? It is equal to 3 by 4. Look, here a equal to 3 and b equal to 4. When we wrote 3 by 4, then we got what? 0.75. So, 0.75 can also be a rational number because why? It can be written in the form a by b. Okay, now look, this is a terminating number, right? Terminating means what? It ends here. It is non-terminating means what? For example, a number something like if this is going on like this, look, is it terminating? No. This type of numbers we will call it as what? Non-terminating. Okay. And then we have to learn about the irrational numbers. The numbers that cannot be expressed as a simple fraction. For example, if pi is a non-terminating number. Okay, if I am taking root 2 is what? Root 2, value for the root 2, we will write it like which is equal to 22 by 7. Its value is equal to what? 3.14285714, like that it goes on. It repeats. And it doesn't follow any pattern too. Here you can see that it is following a pattern, right? But here you can see that these irrational numbers are what? Non-terminating, non-repeating numbers. Okay, here you can clearly see that this is a repeating pattern here, right? 3 is getting, so if I want, I can write this one as what? Like this I can write. It means that this 3 is getting repeated. Clear? So I am able to write this in the form of a by b. But here it is not possible. What about the real number? Real number, the set of all the rational and irrational number together, we will call it as what? Real number. Okay. So once again, what do you mean by this irrational number? Irrational number, they are having non-terminating, non-repeating decimals. So now let's start the theorem here. The fundamental theorem of arithmetic. That's the first theorem that we are learning in this chapter. As per this theorem, every composite number can be expressed as a product of prime, and this factorization is unique apart from the order in which the prime factors occur. Okay, this is what this fundamental theorem of arithmetic says. So, for example, if I'm taking the number 60, okay, what can I do? I can factorize the 60, right? 60 can be factorized as, if I'm dividing it by 2, I will get 30. When again divided by 2, I will get 15. Now I need to divide it by 3, then I will get 5. So it can be written in a which form? 2 into 2 into 3 into 5. So this can be written as 2 raised to 2 into 3 raised to 1 into 5 raised to 1. Now look, these all are what? Prime numbers, right? So every composite number, here 60 is a composite number, it can be expressed as what? Product of prime. And this factorization is what? It is unique apart from the order in which the prime factors. Okay, if I want to reorder this one, how can I write? 3 into 5 into 2 raised to 2. That's also correct. Correct? So this is the fundamental theorem of arithmetics. Now we have to learn about an equation. Here, in this equation, we are taking when two numbers are given, when two numbers A and B is given, if we want to find SCF into LCM of both the two numbers, what this SCF into LCM of the both numbers will be equal to the product of those two numbers. Okay. Similarly, this is an extra part. When three numbers are included, what will be the answer? If I want to find the LCM of A, B and C, what I should do? I should take the product of three numbers into, here they are asking for the LCM. So I have to take the SCF of A, B and C, then divide it by SCF of A and B, then take the SCF of B and C, then take the SCF of C and A, multiply all together. Using this equation, you will be able to find the LCM of the three numbers. Similarly, if you want to find the SCF of three numbers, what you should do? You should first multiply all those three numbers. Then you should take the here SCF, right? So here you should take the LCM of the three numbers divided by the LCM of, first you have to find the LCM of A and B, then LCM of B and C, then LCM of A and C. Multiply all those together and divide it. Now let's do the exercise 1.1. Express each number as a product of its prime factors. First one we have to do 140. So 140, how we can do that one? 140, you can take the smallest prime number, which is 2. Divided by 2, you will get 70. Again, this can be divisible by 2 again, because all those numbers which are ending in 0, 2, 4, 6, 8, these all numbers, they are divisible by 2. Okay, so now I am able to find that this number is divisible by 2 because it is ending in 0. So 70 when divided by 2, I will get 35. Then 35 means I know that I can divide it by 5. 7 5s are 35. So 140 can be written as 2 into 2 into 5 into 7. Right? This can be again written as what? 2 can be written as, how many 2s are there? 2 raised to 2 into 5 into 7. Right? In this way, we have to represent each number. Now, next one, second one is what? Second one is 156. So, 156, how we can do that one? 156, similarly, I have to divide it by 2. Since the ending number is 6, I can divide this number by 2. So, what is that? 7 2s are 14, remainder 1, 16, 8 2s are 16. Then, again, I can divide this number by 2 again. Now 7, right? 3 2s are 6. Then remainder 1, 18. 9 2s are 18. Now if I'm checking this number, this is divisible by 3. That is, I'm getting 1, 3. Okay, and there is one more method to check whether the given number is divisible by 3 or not. Here 39, right? 39, here what I can do? 3 plus 9. What is 3 plus 9? Which is equal to 12. 12 is divisible by 3. Completely divisible by 3. Therefore, we can tell that 39 is divisible by 3. So, how to find whether a given number is divisible by 3? What we have to do? We have to add the number together. Then, the final answer, what we will get, if it is divisible by 3, means that the entire number is also divisible by 3. Okay, so what's the answer here? 2 into 2 into 3 into 13. How can I write this one again? 2 raised to 2 into 3 raised to 1 into 13, right? So this is my final answer. Now the third question, 3825. How to do this one? 3825. We have to check whether this number is divisible by 2. This is not divisible by 2 since the ending number is 5. So we will now go to the number 3. How to check whether this number is divisible by 3? For that we have to add the numbers 3 plus 8 plus 2 plus 5. 8 plus 2 is 10. 10 plus 5 is 15. 15 plus 3 is 18. So this number 18 is divisible by 3. Completely divisible. We will get the number 6. So that means 3825 is divisible by 3. Now we are going to divide it by 3. On dividing we will get 1. Then 2, 7, 5. Now again we have to check whether this number is divisible by 3. How to check that? 1 plus 2 plus 7 plus 5. 12, 14, 15. So 15 is divisible by 3, right? 5 3s are 15. So it means that this number is also divisible by 3. Now we had what we will get here. 4 3s are 12. Then 3 2s are 6. Remainder 1, 15. 5 3s are 15. So we are getting 425. This is again divisible by, if you are checking here, 4 plus 2 is 6. 6 plus 5 is 11. It is not divisible by 3. So now we will go with the number 5. Then what we will get here, it is 85. Again by 5. So we will get 17. So the numbers are what? 3 into 3 into 5 into 5 into 17. So how can I write this one? Which is equal to 3 square into 5 square into 17. Clear? So now we have to do the next one. Fourth one. This is the fourth question. 5005. 5005 means, so here we can do it by 5005, which is divisible by 5. So I will get 1001. Now here after checking we will be able to find that this 1001, it is divisible by 7. So how much we will get? 143. 143, we know that it is divisible by 11. So I will get here 1, remainder 3, 33, so 3. So what are the numbers here? 5 into 7 into 11 into 13. So this is a number. Okay. Now next question. Question number 5. It is 7429. 7429 is divisible by 17. Okay. On dividing it by 17, we will be getting 437. Again, this number, it is divisible by 19. So how much we will get? 23. So the numbers are 17 into 19 into 23. Here also you can check. 17 is a prime number. 19 is a prime number. 23 is a prime number. Prime numbers are the numbers which have only the one and the same number as its factors. Okay. For 17, in which way we can write 17? 1 into 17. So what are the factors of 17? Only factors of 17 are 1 and 17. In the case of 19 also, it have only two factors. What are the two factors? 1 and 19. If I'm taking 23, it have only factors 1 and 23. You don't have any other factor other than these two numbers. Clear? Now next question. Question number 5. It is 7429. 7429 is divisible by 17. Okay. On dividing it by 17, we will be getting 437. Again, this number, it is divisible by 19. So how much we will get? 23. So the numbers are 17 into 19 into 23. Here also you can check. 17 is a prime number. 19 is a prime number. 23 is a prime number. Prime numbers are the numbers which have only the one and the same number as its factors. Okay. For 17, in which way we can write 17? 1 into 17. So what are the factors of 17? Only factors of 17 are 1 and 17. In the case of 19 also, it have only two factors. What are the two factors? 1 and 19. If I'm taking 23, it have only factors 1 and 23. You don't have any other factor other than these two numbers. Find the LCM and HCF of the following pairs of integers and verify that LCM into HCF equal to the product of the two numbers. So first one we have to do the question number 1, which is 26 and 91. Here what we have to do, first we have to find, we have learned our equation LCM into HCF equal to what? Which is equal to A into B. So here first we have to find the LCM of which two numbers? First we have to find the factors of 26. What are the factors of 26? 26 can be factorized as here divided by 2. What you will get? 1, 3. So the factors are 2 into 13, right? 91. Similarly, 91 can be written as what? 91, which is divisible by 7, which is equal to 13 here. So 7 and 13. So what is the HCF here? HCF is 13. Okay. Now what about the LCM? LCM equal to 2 into 7 into 13, right? So here now what we have to do? We have to find HCF into LCM. We have to find it whether it is equal to A into B. In this way we have to verify. Okay, so our verification, now we are going to do the verification, right? Verification, how we have to verify? HCF into LCM equal to A into B. Then here what's the HCF here? 13. And what about the LCM? 2 into 7 into 13 is 182. So that means what? 13 into 182, we have to check whether it is equal to the product of these two numbers. Numbers are 26 into 91. What is 13 into 182? Which is equal to 2366. Similarly, 26 into 91, what you will get? Which is also equal to 2366. So we have verified that, right? That is hence verified. Now we have to do the next question, which is second one, 510 and 92. How to do, first we have to find the factors of 510. 510, it is divisible by 2. So we will get 2, 5, 5, right? Then again this number is divisible by 3. Because 5 plus 5 is 10, 10 plus 2 is 12. So it is divisible by 3. Now when divided by 3, we will get 85. This number, it is divisible by 5. On dividing, we will get 17. Similarly, we have to find the factors of 92. 92 when divided by 2, we will get 46. Then again, this number is divisible by 2. So how much we will get? 23. So factors of 510 are 2 into 3 into 5 into 17. Now 92. What are the factors of 92? 2 into 2 into 23. So what is HCF here? HCF of A and B is, this is one number, then another one is, only 2 is a factor, right? So HCF is what? Our common factor, highest common factor. So which is HCF equal to 2. Now we have to find our LCM. LCM equal to how much? LCM equal to how many? What's the maximum repetition of 2 here? 2 into 2. Then the number 3. What about the 3? 3 one time. Then what about the number 5? 5 one time. Then 17. Then 23. So what the LCM? LCM equal to 23,460. Right? Now we need to do our verification. How to do the verification? Verification, we have to use our equation. What's our equation? HCF into LCM, which is equal to product of the two numbers, which is A into B. What is the HCF here? 2. 2 into, what's the LCM here? 23,460, which is equal to, what are the two numbers? Two numbers are 500 and A is 510 and B is 92. So how much we will get here? Which is equal to this 2 into 23,460, we will get it like 46,920, which is equal to, what is 510 into 92? That again 46,920. So it is verified, right? So we will write hence verified. Clear? Now we have to go with the next question, the third one. Third one is 336 and 54. How to do this one? First we have to find the factors of 336. 336 is divisible by 2. How much we will get? 168. Then again divisible by 2. 8 was 16. So 8, 4. Again divisible by 2. So how much we will get? 42. Again by 2. 21. 21 divided by 3. 7 3s are 21. So now we have to find the factors of 54. 54, what are the factors? When divided by 2, we will get 27. 27 divisible by 3, which is equal to 9. Again divisible by 3, which is equal to 3. So factors of 336 is 2 is repeating 4 times. 2 into 2 into 2 into 2 into 1 times 3 into then 7. Then what about the 54? We have to write our 54. 2 into 3 into 3 into 3. Now this one, then this one, right? So what is our HCF here? HCF equal to 2 into 3. And what about the LCM? 2 is repeating here maximum how much? Which is equal to 2 raised to 4. Then what about the 3? 3 is 3 raised to 3 into 7. So which is equal to how much? 3024. Now we have to substitute the values into our equation. What's our equation? Equation is LCM into HCF, which is equal to product of our numbers, which is A into B. What is the LCM here? 3024. And what about the HCF, which is equal to 6? Equal to what? What are the numbers here? 336 into 54. So how much we will get here? 18,144. That is 3024 into 6 is 18,144. Similarly, 336 into 54 is also again equal to 18,144. So here this is also hence verified. Clear? Now we have to do the question number 4. Given that HCF of 306 and 657 equal to 9, find LCM of 306 and 657. So the given number A equal to what? 306 and B equal to 657. Again, HCF is given. HCF of A and B is given how much? Which is equal to 9. They are asking us to find the LCM of A and B. So here what we can do, we can use our equation HCF into LCM equal to how much? Which is equal to A into B. So what is the HCF given? 9 into LCM, which is equal to A is 306 into 657. So how to find the LCM? LCM equal to what? 306 into 657 divided by 9. So how much we will get? Which is equal to 22,338. Now let's do the question number 5. Check whether 6 raised to n can end with a digit 0 for any natural number n. Okay, so they are asking, in the case of the 6 raised to n, is there possibility of any number? Here the last digit will be 0. So if I am writing the 6 raised to n, for example, first I am giving the value for n equal to 0. So what will be the value? 6 raised to 0, which is equal to 1. We know that any number raised to the power 0 is 1. If n equal to 1, what will be our value? 6 raised to 1, which is equal to 6. If n equal to 2, what is the value? 6 raised to 2, which is equal to 6 into 6, which is equal to 36. If n equal to 3, what is the value? 6 raised to 3, which is equal to 6 into 6 into 6, which is equal to 216. In all these cases, you can see that the ending number is what? 6. Correct? If I am writing the factors of the 6 raised to n, what will be the factors? This I can distribute by writing 2 into 3 the whole raised to n, which is equal to 2 raised to n into 3 raised to n. Here, if I was getting a number 5 instead of 3, then I could have tell that there will be a there is a chance to get 0 as a end digit. Okay, for some numbers. But here 6 raised to n, the possibility is 0, because why? It would be it should be divisible by 5, right? But that is not actually happening here. So it is clear that what, in the prime factorization of 6 raised to n, 5 is not present, right? So we can tell that there exists no any natural number n for which the 6 raised to n end with the digit 0. That is how we have to give the answer for this one. Here 6 raised to n can end with 0 for any natural number n, then it would be divisible by what? It should be divisible by 5. That is what factors of the 6, it is 2 into 3. That is prime factors of 6 raised to n, I can distribute that as what? 2 into 3 the whole raised to n. That is 6 raised to n equal to 2 raised to n into 3 raised to n. So from here what is clear? It is clear that the prime factors of 6 raised to n, 5 is not present there, right? This one we can prove by using our fundamental theorem of arithmetics, right? Why we wrote in this way? Because by using the fundamental theorem of arithmetics, we can tell here if 6 raised to n, let it be any composite number, we can express the numbers of what? Product of the prime, and the factorization is what? Unique. Here you won't be able to find any number which is having 5 as its factor, right? 5 is not a factor in this case. So this chance of getting 0 as a last digit is impossible. So we can write what? Hence there exists no any natural number n for which 6 raised to n end with the digit 0. Clear? Now let's do the question number 7. There is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? This is a question. So here what they are asking us to do, here they are telling about Sonia completes one round in how many minutes? In 18 minutes. And Ravi completes one round in 12 minutes. Correct? They both start at the same time from the same point. So what we have to do here, we have to find how much time both will be back at the starting point together again, right? So if we are checking like this, now look, in the first round, Sonia will reach the field in 18 minutes. Her second round she will take, in order to complete the second round, she will take total 36 minutes. That means including the first and the second round. When she will complete her third round, by the time taken will be 54 minutes. And in the fourth round, she will take 72 minutes. And Ravi, if he want to complete one round, he needs 12 minutes. So he will complete his first round in 12 minutes. He will finish off his second round and reach the position A in his 24th minute. And third round C will be completed at the 36th minute. And fourth round D will be in the 48th minute. Now look here. Sonia takes 36 here, right? When she will finish off this second round, she takes 36 minutes. Similarly, Ravi, when he will complete third round and when he will be in the position A, he will take 36 minutes. So this is the time at which they both are going to meet each other at the same point A. So this means what we need to find here, we have to find the LCM, correct? So this question we need to solve by using LCM. Okay, so how to solve this one? We have to first find what. Now let me write the things which are given in the question. So first one is what? Time taken by Sonia to drive one round of the field, okay, of the field is equal to how much? It's equal to 18 minutes. Similarly, the time taken by Ravi to drive one round of the field is equal to how much? It's equal to 12 minutes. Now we need to take what? Now we have to take our 18 and we have to find the factors of 18, which is equal to 2 into 3 into 3. And what are the factors of 12? 12 is 2 into 3 into 2. So how to find the LCM? LCM equal to 2 into 2 into 3 into 3, right? So which is equal to what? 36. This is what we have already found from this. Correct? So we need to find what? We need to find the LCM in order to solve the question. So hence we will right? Hence they will meet again at the starting point. At what time? After 36 minutes. Clear?